So now we get to integrate functions involving trigonometry. And I haven't really explicitly said this in the videos, but whether you do this in your head or you actually write down this step, you can take constants out of integrals. So we can think of this -8 as being outside of the integral, just like that. And I don't know if that helps or not. But now what we're faced with is an integral of secant tangent. And if you think back to your days of derivatives, you'll recall that the derivative of secant theta is secant theta tangent theta. So what that means is if we want to integrate secant theta tangent theta, that integral is just the secant of theta. Again, integrals are just the opposite of derivatives, but we can use that integral right here. This -8 just sits there. The integral of secant tangent we just learned was secant theta, and we're going to evaluate that from 0 to pi over 3. Now, the Fundamental Theorem of Calculus Part 2 says we plug in that upper limit, and we subtract, and we plug in the lower limit. And this requires remembering a little bit of trigonometry, so this is a good problem. You'll recall that the secant of x is 1 over cosine of x. And if we want the cosine of pi over 3, I always have to draw out a little unit circle. Pi over 3 is this angle up here, and the cosine is the x value on that unit circle. The x value on that unit circle is 1/2. So cosine of pi over 3 equals 1/2. Sorry, I'm just scratching a few things out here. If you want a little more information about unit circle and trigonometry, feel free to find some videos for that online. But if the cosine of pi over 3 is 1/2, then the secant of pi over 3 is 2. We can plug that in right here, and we get -8 times 2. I'm going to turn this minus a negative into a plus. What is the secant of 0? Well, my angle 0 is down here, and that cosine value, that x value there, is 1. So if the cosine of 0 equals 1, that means the secant of 0 also equals 1, or 1 over 1. We just have 8 times 1, and our final answer is going to be -16 plus 8, or -8. Sweet. I like that problem a lot because it reminds us of our important trigonometry skills. All right, good job. I'll see you in the next video.